Hi everybody, this is Jim Corkins again, and we are finishing up energy with this tutorial 3.2. Okay, and this is an example problem from 3.2. In this problem, these problems, they do have work involved. So again, before I even start the problem, I make a little list. I make a list of all the different types of energies. So kinetic energy is 1/2 mv squared. This is the energy of speed. Potential energy due to gravity. This is equal to mgh, and this is the energy of height. The potential energy of a spring is 1/2 kx squared. And so anytime a spring is compressed or stretched, you're adding that energy to the system. So all of these are going to be positive energies. Now work is different. That comes from outside the system. That could add energy to a system, or it could take energy away. So for example, if a cart was moving by at some kinetic energy, and then I gave it a shove in the direction that it was moving across a displacement, that is another type of that is a type of outside work. Okay, so please watch 3.2 and also 3.0 if you want to learn more about work. Another type of work is the work due to friction, specifically kinetic friction. Okay. Now, kinetic friction will always subtract energy from the system. So kinetic friction, mu sub k, will always subtract energy from the system. But you can push a cart to speed it up. So you're going to be adding energy to it. Or you could, if a cart's coming at you and you push against the cart and slow it down, that could take energy away from the system, right? In other words, subtraction means you're slowing down the cart or you're absorbing kinetic energy. Addition means you're adding kinetic energy to that system, okay, and speeding it up. Now what I also do here is I make a little checklist of energies. So above this, I'm going to go EI and EF. And this is going to help me build my first equation. Okay. Now, what I also do is I write this initial equation. This is cueing me to define the initial energy, then define the final energies, and then think about if work is being added to the system or taking away. If you don't know, just make it a positive work and leave it in the system, because the energy stuff will end up working out mathematically. Okay, so here we go. Again, in the homeworks in these energy tutorials, the first sentence tends to define the initial energy. The second sentence tends to define the final energy. And then the third sentence usually asks you to solve for something. So in this case, it's saying we need to solve for F. And I think we're creating an equation in terms of variables. So that's going to be interesting. So here we go. In this problem, this person, this block is a height h up, and it looks like it is moving, and the person is touching it. Okay, so there is a rope touching it, so there is an outside force. And then it falls to a height 0 where it comes to a stop. So now it's not moving and it's height 0. So there's no springs or any of that kind of stuff, but there is a rope. So if you see a rope attached to something, there's going to be an outside force. So we're going to have to deal with this right here. Okay, let's get to it then. Let's define the initial energy. So it's so is it moving? Yes or no? It does have an initial velocity. Is it a height? Does it have a height? Yes, it does have a height. Is a spring touching it? No. So I'm going to note those things right here. So I have an initial kinetic energy. I also have an initial potential energy due to gravity. All right, let's define the final energy. Okay, is it moving, yes or no? So the velocity is 0, so no. Is it at a height? Does it actually have a height? No, it does not. Is a spring touching it? No. So this final energy is just 0 joules. That's kind of weird. How can some energy, when we go to define this, if we're just looking at the energies, let's say it's not moving very fast, but it is up a pretty good height. So it's got 3 blocks. So this is positive 3. Well, there is no energy in the end. Okay, so that's where the works come in. Okay, so that energy right here is going to be coming in. In fact, you could see that positive 3, how do you make positive 3 equal to 0? Well, you have to subtract 3 from it, right? So in other words, if this is up positive 3, this is below by 3. You've got to subtract a 3 here. Positive 3 minus 3 equals 0. So now you know this work is going to be negative. In fact, you're pulling up on this to slow it to a stop. It's moving here and it's slowing it to a stop. So that should have cued you also that that was a negative work as well. Okay. So again, if you're having a hard time with that, please watch 3.2 tutorial. But let's continue on. So this kinetic energy right here, that anywhere you see a K, you put a 1/2 mv squared. The I gets tagged onto that. Everywhere you see a U sub G, that you put an mgh. This work, that is not a frictional work. So it does have a work here, but not due to friction and not due to this. So that is just going to be an F dot, and that, since it's moving in the Y direction, I'll call it like a delta H in this case, is equal to 0. So now what we're going to do, we need to solve for F. So what we're going to do is subtract, we're going to add this onto the other side. So this is going to be 1/2 mvi squared plus mghi, and that's equal to F times delta H. Delta H, by the way, is, in this case, is just going to be, and I'm going to rewrite this right now, that's just H minus 0, right? That is delta H. So in other words, this is just F dot H, right? All right, so now we have to divide this onto the other side. Okay, actually what I'm going to do, just so it looks clearer, is I'm going to grab this whole thing, whoops, I don't know why it's doing that. Control Z. Hold on. Gonna try this again. Grab that right there, and I am just going to remove that. Just going to grab that guy and move it right there. Made that more complicated. I probably could have written it out in that period of time. Okay. So now, the very last step to solve for what F is, I'm going to divide this onto the other side. So that's going to be 1/2 mvi squared plus mghi. Divide that whole thing by h, and that is equal to F. And that's what Mark is asking you to do in that problem for that tutorial. Okay. Again, I want to make sure that you practice one procedure to do these problems, and this procedure fits perfectly with all problems in energy. All right. Thank you very much, and I hope you have a great day.